Today's story has no hard formulas at all. Addition, subtraction, multiplication, division, just those four. And yet, by the time it's over, one tiny explosion goes off, where a fact almost too easy slams head-on into common sense. Before the main story, let's get just one question right. We take 100 kilograms of potato that is 99% water, dry it in the sun, and bring the water down to 98%. We drop it by exactly 1 percentage point. Around 99 kilograms? Maybe a generous 98 kilograms? Write that answer down in your mind. By the end of this video, you'll see that this intuition is off from reality by a staggering factor of 50. On a sunny day, say you bought a whopping 100 kilograms of potato at the market. Real potatoes are about 80% water, but today we'll use our very own magical math potato. 99% of its weight is water, and 1% is pure potato solids. Why pick such an extreme as 99%? The more extreme the number, the more dramatic the result. Cut open the 100 kilogram sack, and you'll find 99 kilograms of water, and just 1 kilogram of pure solid. Picture it and it's a bit absurd. This is less a potato than a giant water balloon, water sloshing inside a thin skin. Those 99 kilograms of water amount to about 50 of the 2-liter bottles of water. Let's switch to a classroom analogy. It's a class of 100 students, but 99 of them are water friends, and only a single one is the real potato. Let's name this little friend Donmu, after the firm solid core. He's the true hero of today's story. Keep this small firm 1 kilogram fixed in your mind. The real hero of this entire story is precisely this 1 kilogram. We spread this potato out across the yard and stepped out for a while. In the meantime, the hot sun evaporated just a tiny bit of moisture. A few water friends rose into the sky and vanished, while the solid core, Donmu, quietly held his ground. Back home we weigh it again. The share of the total weight taken up by water had dropped from 99% to 98%, down by exactly 1 percentage point. So, how many kilograms is this sack of potato now? Our minds will instinctively whisper, about 1% of the water flew off, so from 100 kilograms maybe 1 kilogram is gone, making 99 kilograms. Even at the very most 98 kilograms, surely it can't drop below that. But when you set the potato on the scale, you're left speechless. The number on the display is neither 99 nor 98, but 50 kilograms. Tap it, set it down again, still 50. Yes, you read that right. The water fraction fell by a mere 1 percentage point. Yet the sack's weight shrank to exactly half. The gap between your estimate of 99 kilograms and the correct answer is a whopping 49 kilograms. The 50 kilograms of vanished water weighs more than half a sack of rice. By now you might be getting angry. How can 50% disappear when only 1% dropped? But the potato never told a single lie. The one that lied was our intuition. There's only one reason we got so cleanly fooled. We kept our eyes only on the water that flew away. It's exactly like a magician waving one hand to draw your gaze, while the other hand hides the secret. Escaping the trap is surprisingly simple. Don't watch the water that leaves, watch Donmu, who holds his place to the very end. No matter how hot the sun gets, only the water evaporates. The firm solid can't fly away. A quantity that refuses to change no matter what happens has a dignified name. An invariant. The harder the problem, the more dropping anchor on one such value that stays put will show you the way. Now let's set the two scenes side by side. Before evaporation, the sack is 100 kilograms, the core is 1 kilogram, 1% of the whole. After drying, the sack is the value we're hunting for, but the core is still 1 kilogram. Here comes the decisive step. If after drying water is 98%, what is the rest? A potato is either water or solid core, one of the two. So the core's fraction is 100% minus the water fraction. If water took up 98%, the remaining core is 100 minus 98, that is 2%. Now two facts are in our hands. The core's actual weight is unchanged at 1 kilogram. Yet the fraction that core takes up is now 2%. Put them together. 2% of some total weight is exactly 1 kilogram. At first, 1 kilogram was 1% of the whole. Now that same 1 kilogram is 2%. We never touched the core. Yet its share doubled. Donmu didn't grow. The water friends beside him left. Let's move to the classroom. To raise Donmu's share alone from 1% to 2%, you'd have to send away the water friends from 99 down to 49, a full 50 of them, leaving a class of 50. And Donmu just sits there. A moment ago we arrived at the sentence, 2% of the whole is 1 kilogram. Let's flip the question. If 2% is 1 kilogram, then how many kilograms is the whole 100%? To turn 2% into 100%, what must we multiply 2 by to get 100? Exactly 50. The rule must be fair. Since we multiplied the fraction by 50 to make the whole, we multiply the paired weight by 50 as well. 1 kilogram times 50 is 50 kilograms. That's all there is to it. The sack's total weight must be 50 kilograms. Only then does the unchanging 1 kilogram core fit the fraction of 2% exactly. Summed up in one line, what we just did becomes one dignified little formula. We simply wrote in symbols the statement. Take the weight of the solids and divide it by the fraction that the solids make up. By this formula, dividing 1 kilogram by 0.02 also gives the same 50 kilograms. Multiplying by 50 and dividing by 0.02 are one and the same thing. Now let's check how much water vanished. 100 kilograms became 50 kilograms, so the water that flew off is exactly 50 kilograms. Checking it. From the initial 99 kilograms of water to the final 49 kilograms, 99 minus 49 is 50. A perfect match. That differs from our initial guess of about 1 kilogram by a staggering factor of 50. That intuition can be this badly off is the very reason the potato paradox is recounted again and again. The arithmetic clearly says 50 kilograms, yet a corner of your mind may still feel uneasy. That's perfectly normal. So let's set the potato aside for a moment and switch to friendlier marbles. There are 100 marbles in a box in all. 99 white marbles are the water, and 1 red marble is the core, that is, Donmu. Our goal is to add not a single red marble, yet raise the red marble's fraction to 2%. For 1 red marble to become 2% of the whole, 2% means, in other words, 1 out of 50. So the marbles in the box total 50. Since we can't touch the red marble, we just remove 50 of the white marbles. Here's the aha moment. The act of merely doubling 1 red marble's share from 1% to 2% meant throwing away fully half of the white marbles. This is exactly the same as evaporating 50 kilograms of water from the potato. Now let's get a little greedy. We'll run the same arithmetic, varying the water fraction to other numbers too. The method is always the same. Take the unchanging 1 kilogram core and divide it by what percent of the whole it is. Let's lay it out in a table. At 99% water it's 100 kilograms, at 98% it's 50 kilograms, at 95% it's 20 kilograms, at 90% it's 10 kilograms, at 80% it's 5 kilograms, and at 50% it's a mere 2 kilograms. Scan this table from top to bottom and a vivid picture emerges. Up at 99%, blowing off just 1 percentage point halves the weight. But down around 90 or 80%, that same 1 percentage point isn't nearly so violent. Try it yourself. Take 1,000 kilograms of potato that is 99.9% water, and bring it to 99.8%. The core is 0.1%, that is 1 kilogram. It has now become 0.2%, so the whole is 1 divided by 0.002, that is 500 kilograms. Cut in half again. Why is it exactly half precisely when we go from 99 to 98? Because the core's fraction doubled exactly, from 1% to 2%. For the core's fraction to double while its weight stays the same, the total weight must do the opposite, become half. Picture it as a cake. Cut the same cake into 50 slices and 1 slice is small. Cut it into 2 slices and 1 slice is large. To make a single slice twice as thick, there's no choice but to shrink the whole cake by half. Double means half. This elegant seesaw is the heart of the paradox. So far we've played with the potato as a toy, but this very same trap stalks us every day, at the store, in games, in the kitchen. First, the discount trap. Knock 50% off 10,001, then 50% off again and you think it's free. Not a chance. The first discount cuts 5,001. The second 50% is half of that 5,001, so it only cuts 2,501. In the end it's not 01 but 2,501. We missed that the base for the second percent had shifted to the reduced price. Second, gotcha pulls in games. Raising a character's drop rate from 1% to 2%, just 1 percentage point might sound trivial. But this is a gift that doubled your odds. What averaged 100 pulls drops to exactly half 50 pulls. Third news headlines. If a mortality rate falls from 2% to 1%, 1 percentage point, it may seem like no big deal, yet it's the enormous news that the number of deaths was cut in half. A value attached to 100% hides great meaning in a single percentage point. Fourth, the kitchen and the salt flats. To concentrate 1% sugar water up to 2%, you must evaporate fully half the water. Seawater is about 96.5% water, so to reveal the unchanging salt you have to drive off most of the water. The potato has merely moved to the kitchen. Now the most important question. The arithmetic is this easy, so why did intuition so confidently shout the wrong answer? Let's summon the suspects who fooled us one by one. Suspect 1, the real culprit. Charged with mistaking the one of a fraction for the one of an amount. What's more, going from 1% to 2% is at once a rise of just 1 percentage point and an exact doubling, yet our minds see only the small face plus 1, and miss the big face times 2. Second, charged with being bewitched by the changing water and ignoring the unchanging core. Third, also a real culprit, charged with missing that the base for the percent shifted midway. The base for 99% was the initial 100 kilograms. The base for 98% was the post-drying 50 kilograms, different holes. Fourth, charged with swapping a hard question for an easy one. The arithmetic we need is the unfamiliar division 1 divided by 0.02, but the brain reflexively grabs the friendliest one, 99 minus 98 is 1. And so we are wrong, but very confidently wrong. In the end, it all shrinks to a single sentence. Whenever you see a percent, you must first ask a percent of what, that is where the baseline lies. Today, with no hard formula at all, using only addition, subtraction, multiplication, and division, we arrived at a truth that outruns intuition by a factor of 50. Mathematicians call this kind of problem a veridical paradox. It means a paradox whose conclusion looks utterly unbelievable and absurd. Yet when you scrutinize it line by line, every single step is true, so in the end you have no choice but to accept it. The potato paradox is exactly that. Absurd, yet not a single falsehood anywhere. Let me pack away today's lesson in a one-line summary. Hold on to the unchanging core, and find the total weight by reading it backward: mass of solids divided by solids fraction. The lesson beneath it is shorter still. When the changing things bewitch us, just hold on to what does not change. Not the water flying off, but the 1 kilogram that quietly remained. The moment you saw Dawn move 50 kilograms was no longer a mystery. Whenever you hear somewhere that it dropped only 1%, or that it's a mere 1 percentage point difference, quietly ask back, so, 1% of what exactly? You who hold that question have already grown a notch taller than yesterday. If you enjoyed today's video, please subscribe, like, and turn on notifications. See you in the next video.